Okay, guys, this video, I'm gonna explain the MapReduce application source code. It is important. In other videos, I already explained how to pack the source code into package and how to run it, how to check the output of your MapReduce application. But in order to develop a MapReduce application, for sure, you need to know the source code structure, okay? So here, let's get started. Here, I'm already in my virtual machine environment, okay? So we use Eclipse to editing Java source code. So if you haven't opened Eclipse, then go ahead, open it. For me, I already opened it and minimized right here. So I just called it back. If you haven't opened it, double click and open it, you will see the source code. Okay, here, if you go to the left-hand side, collapse the menu until you see the 3 source code. Why 3 source code, Java source code here? The reasons we already explained in other video. Okay, so here we directly dive into the source code and explain how this works and what's important. First, the mapper, MapReduce. So there's a mapper reducer. These are the 2 source code, the core of your application. And the other one is a job runner. So let's look at mapper first. Double click it, open it. These are the Java source code of your mapper. Before we dive into the source code, let's quickly look at the application structure. Okay, how to find this structure. Go to Blackboard and PPT, and here in this item, developing MR app, click this menu, the picture, and you will see this picture. The Java source code we are showing here is the maximum temperature application example. Okay, also the textbook also using this example. So the maximum temperature in this MapReduce application, the map, or called mapper in Java source code, was just 2 things we need to know, okay, as a developer. First, the data input to your mapper. Second, what your mapper need to do. I'm sorry, I mentioned 2 things, actually 3 things. The input, output of your data of your mapper, and then what your mapper need to do. So essentially, your mapper take the input, manipulate the data, and send output out. Okay, so the input, manipulation, and output. The input, as we explained before, would be a pair. So every time your mapper is called, the function is called, a pair of data will be passed along to you. So the mapper gonna receive a pair. The key is the line number. So the line and the value is the line text. This go back to the source, the data file. In the data file, the data is organized line by line. Each line is a weather reading. So each line is a number, line number 1, line number 2. So every time the framework take one line and making a pair, the line number and line text and pass to map. The map need to go to the whole line, try to find out the year and temperature, and then make into a pair and pass it along to shuffle. This is the logical model. So let's look at the program, how that was implemented. First, this is a class. A class has been defined, and this class is a subclass of mapper. Mapper class is a Hadoop framework. Excuse me. The mapper class is a parent class. The parent class, where does it come from? It's from Hadoop framework. And after the mapper class, there is a data type declaration, okay? So we're gonna go back here later. Right now, let's look at to this function or methods. This method name is called map. As name suggests, this is your mapper function. what the mapper function need to do. The mapper function need to take the line of text, find the year and temperature inside the line, make a pair, and send it out. So how that was implemented. First, the mapper function receives a pair, and this pair comes here. The key and the value, just two variables, represents the key and the value, okay? As we said before, the key is the line number, value is the line text. The line number in our specific application, we don't do much about it. We just go to the value, okay? So first line, value to string. This part convert the text data type into string data type. Why? Because the text data type is defined by Hadoop framework. The string data type was defined in Java native programming. So there's an interface. Hadoop using its own data type for various reasons. Most important reason is for data wrapping up and transmission in network. Okay, so the text data type needs to be converted into a string data type. Okay, which is the first line is about. Nothing changed. It's use a different data type. It's actually the value will be the same. The line of text. Next, the line substring from 15 to 19, and that will be your year. Okay, this line finds the year. So in the whole line of text, the year, the 4 digits of year located in this position from 15 to 19. Okay. And how do I know it's 15 to 19? The answer is that you go to data format specification. So in this PowerPoint, we have that data file format specification. Okay, I already opened one. In this specification, if I search for year, okay, Y-E-A-R. Let's go to the beginning, so we'll find the first occurrence. Maybe not year, but just search for date. Date, keep searching, searching. Date. So 15 to 23. Is that right? Yes. So this date consists of 4 digits of year, 2 digits of month, 2 digits of day. Okay. We only need the first 4 digits, which means 16. From 16, take 4 of them there. Okay. Mapping back to Java, we take 15 to 19. So this line raises several questions, I bet. First, why 15? Why not 16? Because in the specification it says 16, okay? The answer is that Java count strings beginning with 0. So given a line of text, the first letter, if in the Java's eye, the first letter position is 0. But in human's eye, in the specification, the first letter of line of text, the first letter position will be 1. That's why in Java, it says 15, not 16, okay? And 15 to 19, it takes 4 digits. Some people may ask, well, 15 to 19 is 5 digits, okay? But this again goes back to the Java programming convention. Java programming, when you try to take a substring, a part of the string from the whole string, you're given the beginning index, ending index. And the beginning index, ending index, the Java gonna take from the beginning index until before the ending index. In other words, it does not include the ending index. So from 15 to 19, essentially, Java gonna take from 15 to 18. That goes to 4 digits of year, okay? Next line, you're gonna find your temperature, air temperature. the position is 87 to 92. How do I find it again? The position, I go reading the specification, find the position there, okay? And this part is the air temperature reading. This part, wrapping it, is try to convert the reading into a number, integer, okay? So this is your air temperature reading. Next several lines is the data verification. Because your air temperature reading is not always good. Okay, sometimes it could be erroneous, or no, not, it's missing value, and a lot of reasons. So there's one more digits. It's called quality control. Just after your temperature reading, position 92 is a position. After your temperature reading, the next one digit is a quality control. Again, how do I know it's a quality control? Quality control, I go to reading this specification and find out it, okay? So this line asks two questions. First, is the air temperature reading is a missing value? The missing value defines as for 9999. If your air temperature reading turns out it's 9999, then it's not a good value, it's a missing value. How do I know 9999 represents the missing value? The specification defines that. Okay, if you go to read air temperature, go next. Temperature, here is my temperature position, okay? And it says positive 999 is a missing value, okay? So if our temperature reading is 999, then it's not good. So if it's not equal to 9999, it's good. And quality, the next digit of quality. Go to the specification, 93, the next digit is air temperature quality code. And here's a list of values that indicates is your temperature good or not. So we say if the quality control is one of these values, 0, 1, 4, 5, 9, is one of these values, then we want it. It means good values. If everything good, if the value pass the quality control checking, then we pass the value along. How do we pass the value along? Go back to our model. We make a pair consisting of year and temperature readings and pass it along. So here, I put a year wrapping it up using the text type, which is the data type defined by Hadoop. So text, and the value is air temperature, wrap it up using the int writable, which also Hadoop-friendly data type. So this is my pair. How do I write my pair out? I use the context variable, call the function called write. So put this pair into a context. I give this my pair to context, and context will take care of the rest. Where does context come from? It passes along when Hadoop calls your map function. Hadoop calls your map function, gives you the pair of value and give you the context, lets you pass along your results. Okay, to wrap it up, your map function, we need to pay attention. The input, pair, value, and data type, output, pair, value, and data type, okay? So that these four data types are clearly declared right here when you define your class, okay? So this is the end of Mapper. I'm gonna use other videos to explain Reducer and Job Runner.